Okay, so now we're going to talk about vertical stretches and vertical compressions. So a vertical stretch or compression is going to change the amplitude of a sine curve. In fact, typo here, the value of A is the amplitude of a function. So whatever the A value is, it will be the amplitude. So if A equals 1, the graph will have an amplitude of 1. If A is greater than 1, it's going to be vertically stretched from our original curve. And if A is a fraction between 0 and 1, then it's going to be vertically compressed. It's going to look shorter. So we're going to do two questions. We're going to graph two equations so that we can see the difference. We'll start off with y equals sine x. Well, y equals sine x, we know has a period of 90 or 360. So 30, 60, 90. 90 is the critical interval. 180, 30, 60, 90, 270, 30, 60, 90, 360. Again, the variable we used was x. Now, I want to be able to go up to 1. So I'm going to make this 1, and I'm going to make this negative 1. Now, I chose to go up to the second one here for a reason, and it'll come apparent in a minute. So I come up to 1, I come down to negative 1. So remembering the sine curve, what does it look like? It looks like 0, 0, 90, 1, 180, 0, 270, negative 1, and 360, 0. Those are your critical points, right? So it's going to be here, 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 and here. So it goes like that, like that, like that, and like that. There's y equals sine x. Now what we want to do is we want to sketch y equals 2 sine x. So what's changed here? Well, the point notation is a little bit different. Each one of these points was x, sine x. And we want it to change to x, 2 sine x. So instead of sine x, we're going to multiply it by 2. So this will be 0, 2 times 0, which is 0. I multiplied this 0 by 2. This will be 90. 2 times 1, which is 2. 180. 0 times 2, which is 0. 270. Negative 1 times 2 is negative 2. And 360. 0. So each of these points gets moved according to this transformation. Let's see. 0, 0 didn't move. 90, 1 goes to 90, 2. Okay. So 1, 2. Now you see why I didn't use up too much of the vertical axis. So this point actually goes to here. This is 90, 2. 180, 0. 270, negative 2. And 360, 0. So what we have here is a taller curve. It's been vertically stretched. And what's changed is this distance, which was 1, has been stretched, so it's now 2 units. And this distance, which was negative 1, has been stretched, so it's negative 2. And all of these others have been stretched. Now these ones didn't move because they're at 0. If you stretch 0, multiply 0 by a number, it doesn't go anywhere. So this is what's called a vertical stretch. And we call it a vertical stretch by a factor or a multiple of 2. So that was a vertical stretch. Now, think about the period. it didn't change. They're both 360. However, the amplitudes changed quite a bit. The blue one has an amplitude of 1. This red one has a maximum of 2 and a minimum of -2. That means that if you take 2, subtract -2, it's 4, divided by 2, the red one has an amplitude of 2 units. 2 units up, 2 units down. The blue one has an amplitude of 1 unit. That also changes the range. I go from +2 to -2 with the red one, where with the blue one, I only go from -1 to +1. The horizontal axis doesn't change. It's still y = 0. Well, the next example is still a vertical something, but instead of being a vertical stretch, we're going to be looking at a vertical compression. Our first curve that we're going to sketch is sine x. Let's take a look at that again. So y = sine x, giving me my points, my important points. It's going to be 0, 0, 90, 180, 270, 360. I find it easier just to write them out. And then we're going to go from 0 to 1, back down to 0, to -1, to 0 again. So we're looking at 90, 30, 40, 60, 180, 30, 60, 270, 30, 60, 360. And I'm going to go up to 1. I'm going to let this be 1 this time, and you'll see why in a minute. I'll let this be -1. So sine x is going to look like this. Here, 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 and here. Now, this still only has an amplitude of 1, even though my scale is bigger, okay? So this actually has an amplitude of 1. I'm only going up to 1. When I look at a = 1/2, though, what happens is each of these points gets changed to 1/2 of sine x. So 0, 90, 180, 270, 360. 0 divided by 2, or 0 times 1/2 is 0. 1 divided by 2, or times 1/2 is 1/2. 0, -1/2, 0. So what we're going to get is, that's half, that's -1/2. We're going to get a shorter curve, a vertically compressed curve. The amplitude is not as great as here. This amplitude is 1. This amplitude is going to be 1/2. So the distance between here and here is only half a unit compared to the distance between here and here, which is 1 full unit. Notice, other than the range and the amplitude, nothing else changes on this curve. And this is called a vertical compression. Okay, I'm going to stop there and then we'll do the last video.